So this lesson is about simplifying algebraic expressions. Simplify, it mentions in your book here, is where we have no like terms and no parentheses. So you can underline that in your book, highlight it, or you can rewrite that. So that's our goal when we simplify. We've taken care of combining like terms together, and if there's any parentheses, if we're able to, we have distributed to those. So we can look at the examples in your book here. First example in your book, we have x plus x plus x. So the deal is, anytime you have a variable, you can have a coefficient, which is just the number that's in front of your variable. So with these, x plus x plus x, what we want to think about is what number could we multiply by something that doesn't change it? 1, right. So what we can do is put 1s in front of all these x's. And by doing that, just like 1 plus 1 plus 1 is 3, 1x plus 1x plus 1x is 3x. Okay? In other words, you know, we added a number together 3 times. That's the same as taking 3 times that number. Yeah.
So could we do, would we do 3 times x or 3 times x times x times x?
Just 3 times x. Yep. Okay. Similar example in your book, it's 2y minus y. So again, the y, we could put a 1 in front of that. Okay. And just like 2 minus 1 is 1, 2y minus 1y would be 1y. Okay. Now 1y, that would be the same thing as y. So if you just put a y instead, that's fine. More commonly, you'll probably write it as 1y to begin with, at least. Okay? So let's look at the try it at the bottom of the page. On the try it then, we've got 4z minus z plus z minus 2z. We're going to try to combine this all together. So if you'll notice the second term there, the z, the minus z, they made that as minus 1z. Okay, we can put a 1 there in front. So then similarly, for that next term, Evan, we could do what?
Um,
1z, right. Okay? And then the last part, we can just bring that down as minus 2z. Nothing changed there. Okay? At that point, we're going to combine these together. What the book's doing basically here is they're basically factoring out a z. So they're looking at all the coefficients and, you know, similar to what we did in the last lesson, they're factoring the z out. Instead of putting it in front of the parentheses, they're putting it behind it. But, you know, it's kind of like z times what equals 4z would be 4. And then z times what, you know, would be a 1z. Well, it's minus, but minus, and then that would be a 1. And then, so this, basically, we're just taking all the numbers in front of our variables and putting them here. And we don't have to do it this way. I'll talk to you guys more about it in a minute. But, and then we basically just subtract those out. So we got 4 minus 1 is 3. And then 3 plus 1 is 4. 4 minus 2 is 2. So altogether, we simplified that thing down to 2z. Okay. Now again, rather than actually doing this step here, if you guys want to skip the second to last step here, that's okay. You could just think one step at a time. 4z minus 1z is 3z. 3z plus 1z is 4z. And then 4z minus 2z is 2z. Okay. Mary Beth?
how'd you get the 1 in the third row? How did they get the 1?
Right here?
No, the other, the next row down.
Oh, the next row down? The one in the box.
The one to the left of the box.
Just because we had a minus 1 here. that okay? Mm-hmm.
Do you always have to put like Z? Can you just put 2 instead of 2Z?
For the answer? Well, let's say Z was equal to 1,000,000. So 2 times 1,000,000, is that the same as 2?
Yep.
Alright, we better put the Z there. So we're going to skip ahead, page 164. Do you know how? We're trying to simplify these expressions. So number 6, we have x plus x plus x plus x.
You put the ones in front of the x's.
Mm-hmm.
And then that would be 4x.
Good. Just like 1 plus 1 plus 1 plus 1 is 4, 1x plus 1x plus 1x plus 1x is 4x. Again, that just simplifies things for us. Instead of, later on if they tell us x is equal to 10, instead of putting it in 4 different places and then adding everything together, we just have one place to put it, and then we multiply and we're done. Okay? Number 7, we've got 4y minus y. So second, y doesn't have a number in front of it. We can put a 1 there, and then 4y minus 1y would be 3y. Good. Okay, just like 4 minus 1 is 3, 4y minus 1y is 3y.
Um, 7y minus 6y,
Mm-hmm.
which is 1y, or is y. And then, would you do 1y minus 4.5?
Good. Those are not like terms, so we just bring that behind there. Okay, and again, yeah, 1y minus 4.5, or you could just do y minus 4.5. Either of those would be acceptable. Uh-huh.
Would you do 7y minus 4.5 and then get 2.5y and then...
Well, does this have a y next to it?
Oh,
Better not do that then. Okay. For us to combine them together, they have got to be like terms. So like terms means if one of them has a letter, the other one has the same letter. If one of them doesn't have a letter, if it's just a constant, a plain number, then the other one would be just a plain number also. Mm-hmm.
I have 2 questions. One, are we going to be doing stuff with, like, fractions?
Going back to example 2 on page 163. Says a new hiking trail includes 3 sections of an old trail. There is a flat section, a hilly section, and a winding section. The park ranger marked the sections of the trail in relation to the length of the flat stretch of trail, which is in meters. What is the simplified expression that describes the lengths of the new trail? Okay, so you can see on the picture here we've got a n, 2n plus 4, and a 2/3 n. So we're trying to find the total length of this trail. So we're just going to add those together. So like we've been doing here, the n, we can put a 1 in front of that as 1n. And then the rest they just brought down. And then these 3 terms that have the n's we can combine together. Now again, the book kind of is factoring the n out. You don't necessarily have to do that as a separate step. What I would do here, probably combine together your whole numbers. So maybe say, we're just adding these together, so I can change my order. 1n plus 2n would be 3n, plus 2/3 would be 3 and 2/3. So 3 and 2/3 n plus the 4. The 4 is just a constant that's just got to go in behind there by itself. So 3 and 2/3 n plus 4 would be our total length of the trail. And again, rather than having 3 different spots we have to substitute an n, now I only have one place I have to substitute an n. Example 3, this summer Vanna wants to charge 2.5 times as much for mowing and raking, but her expenses, $10 per weekend, will also increase 2.5 times. The expression below can be used to find how much Vanna will make this summer mowing and raking X lawns in a weekend. And then it says, how can you use properties of operations to write a simplified equivalent expression without parentheses? Okay, so they got their expression here. If we do X lawns, so we've got 2050 times X would be for mowing the lawn, what we earn. The 550X would be what we make for raking the cut grass, and then the minus 10 is for the expenses. That's what it was. Now she's thinking about charging 2.5 times as much, but again, her expenses are also increasing, you know, so maybe gas prices went up or something, so she has more expenses, so she's raising how much she's charging. So what they're doing here, first of all, you guys remember with the order of operations, first thing we're looking at is what? Order of operations, first thing is parentheses, right? So inside the parentheses, I'm looking to see if I can do anything. So on this one, inside the parentheses, we actually have two terms that we can combine together. Two terms that have x's with them. So 20.50 plus 5.50x, we added together, we get 26x. And then after they worked that out, there's nothing else we can simplify in there. So the next thing they distributed. So 2.5 times 26x minus 2.5 times 10. And that gives us 65x minus 25. That's our equivalent expression and simplified.